Hi, in this video, I'm going to show you how to do a non-parametric test to compare multiple sample for independence, to establish independence between these samples. And the test that we're going to talk here is Kruskal-Wallis test. In the previous video, we talked about another non-parametric test, which is the Mann-Whitney test. Right. So then what's the difference? Well, the main difference between Mann-Whitney U test and Kruskal-Wallis test is that Kruskal-Wallis test actually can test more than two samples, whereas Mann-Whitney U test can only test two samples. So if you have more than two samples, what is suitable is Kruskal-Wallis test. And remember, this is non-parametric test. That means only when your data is not normally distributed, you would use this. If it is, if the data is normally distributed, then you have to use the parametric test, such as t-test, other parametric test, but not the non-parametric ones. Non-parametric tests are useful only when the distributional assumptions are not met. Okay, so as I said, it's a test to sort of non-parametrically check the independence of two or more samples. And so what's important here is not just two, but it could also check more samples at the same time. And it's useful when data is not normally distributed. So to take an example, that's the best way to learn a concept. So we'll take an example of air quality. So in this data, you have ozone level, you have other variables also, and you have month. And what we're interested in is that that whether the sample for different months they're independent or not. All right, so that's what we would like to know. So what we will do is that we will use the Kruskal dot test is the function in R, and the syntax is more like a linear regression syntax, where in the left hand side you have ozone level and then you have month. So you are kind of regressing just to see whether the different sample across different months are independent or not. So the null hypothesis here is that the samples are independent. The alternative hypothesis is that the samples are not independent. And we will try to do this hypothesis stating at 95% confidence level. So what was important for us to know is what is the p-value. If the p-value is less than 0.05, then we will reject the null hypothesis. Okay. All right, so let's see. So this is the data set. Let's run it. All right, so as you can see, the p-value is less than 0.05, so we reject the null hypothesis. So we reject the null hypothesis, and we do not reject the or accept the alternative hypothesis, which is that the samples are not independent. Right, so that's the way you can do a non-parametric test to compare samples, and yet it is a hypothesis testing. Oftentimes it is understood that if the data does not follow normal distribution, then you simply cannot use hypothesis testing. Well, you can use hypothesis testing, but not the parametric one. You can use the non-parametric type hypothesis testing, and we have seen a couple of them, right? One is Mann-Whitney test. Here we have used the Kruskal test, but there are also other non-parametric tests you can use to compare samples if these normality assumptions are not met. Thank you.